Hello everyone. In this class, we will learn gamma distribution. Gamma distribution is one of the continuous probability distribution. Before we know about gamma distribution, let's start with gamma function. What is gamma function? Gamma function is generally defined on positive real number. So the definition is for any positive real number alpha, gamma function of alpha is denoted by the symbol like this, read as gamma alpha. And it is defined as the formula gamma alpha equals to, it is the infinite integration form, integral 0 to infinity x power alpha minus 1 into e power minus x dx, where alpha is positive real number. This is the definition of gamma function. We have some properties of gamma function here. First one is gamma n equals to n minus 1 factorial. This indicates the relation between gamma and factorial for n equals to 1, 2, 3 and so on. In earlier classes, we have n factorial equals to n into n minus 1 factorial, 0 factorial equals to 1. Second property is if we put alpha equals to 1 in this definition, then it is gamma 1 equals to x power 1 minus 1 here. X power 1 minus 1 means x power 0, that is equals to 1. The remaining part is integral 0 to infinity e power minus x dx. The third one is gamma alpha plus 1 equals to alpha gamma alpha. Fourth property is integral 0 to infinity x power alpha minus 1 e power minus lambda x dx is equals to gamma alpha by lambda power alpha, where lambda greater than 0. Fifth one is gamma 1 by 2 equals to root pi. Root pi. These are all 5 properties of gamma function. Now look at the graph of the gamma function here. Generally the graph of the gamma function is in U shape. Suppose the horizontal line indicates the x-axis and the vertical line indicates y-axis. This is in U-shaped curve. On horizontal line we have the values 1, 2, 3, 4 and so on, and vertical line also 1, 2, 3, 4 and so on. Suppose for alpha equals to 1, by the definition of gamma 1 equals to 1 minus 1 factorial, that is equal to 0 factorial, that is equals to 1. It indicates the dotted line here. So now start with the gamma distribution. So gamma distribution is the continuous probability distribution. The definition of gamma distribution for PDF, that is probability density function, is a continuous random variable x is said to have gamma distribution, then its PDF is f of x is equals to x power alpha minus 1 into e power minus x by gamma alpha. This is the PDF value when x greater than or equals to 0. Otherwise, this PDF value is f of x is 0 in all cases, means otherwise. This is the probability density function for gamma distribution. Here alpha is a parameter where alpha is always greater than 0. This gamma distribution is also known as the first kind of gamma distribution or standard gamma function. The first kind of gamma distribution or standard gamma distribution. Now look at the definition of gamma distribution of the second kind. Gamma distribution of the second kind, the PDF value is, probability density function formula is b power alpha, beta power alpha, x power alpha minus 1 into e power minus beta x by gamma alpha. This is defined only x greater than 0 case. So PDF value, this is the PDF value when x greater than or equals to 0. PDF value is 0 in all other cases. This is the probability density function formula for the gamma distribution of the second kind. Okay, observe this definition here. alpha and beta are the two parameters. Those are positive real numbers. Here two parameters. In these two parameters, alpha is called shape parameter and beta is called scale parameter. Now we have an important point here. If beta equals to 1 in this definition, beta equals to 1 in this definition, there is no beta value in PDF of this. So f of x is equals to 1 power alpha x power alpha minus 1 e power minus x by gamma alpha. There is no beta value. Then the above PDF can be converted into x power alpha minus 1 into e power minus x by gamma alpha, where alpha greater than 0. It is similar to gamma distribution of the first kind. Gamma distribution of the first kind. Okay. So if beta equals to 0, the second kind of gamma distribution is converted into gamma distribution of the first kind. Now look at the graphs of gamma distribution of the first kind and second kind too. Remember, alpha is a shape parameter, beta is a scale parameter. How alpha is a shape parameter, beta is a scale parameter? By using the graphs here. Look at the graph here, the horizontal line and vertical line. The horizontal line indicates x and vertical line indicates f of x. Now these are the values on x-axis and y-axis like this. If we write alpha equals to 1, in the definition of alpha equals to 1, we have the property in the second point here. Gamma 1 integral 0 to infinity e power minus x dx means exponential function. We know the exponential function graph like this. This is the exponential function graph. This occurs when alpha equals to 1. This is the graph of e power minus x. If we put alpha equals to 2, the graph may be like this. This indicates the graph for alpha equals to 2, and so on. For example, if alpha equals to 3, the graph may be like this. This is the alpha equals to 3 graph. So observe this graph carefully. There is a graph involves only one parameter, means alpha. So we conclude that graph with a single parameter. This is the graph with single parameter. This belongs to gamma function of the first kind. Now look at the graph here, gamma function of the second kind graph. So this graph involves generally two parameters, alpha and beta. If we fix first parameter alpha constant and we change the second parameter beta here. Suppose if we fix alpha at 3 and beta can varies, beta equals to 1, beta equals to 2 and so on. If beta equals to 1, the graph may be like this, and if beta equals to 2, the graph may be like this. So observe this graph carefully. When we change the beta values, means if we increase beta values, then the scale of the diagram, means the scale of the graph or curve is increased. So peak of this graph increase for different values of beta. Okay. This graph belongs to gamma distribution of the second kind. Here we have an important note. The important note is exponential distribution is a special case of gamma distribution. Why? If we put alpha equals to 1 and beta equals to 1 in gamma distribution, it can be converted into exponential distribution of the exponential distribution. So in this, if we put alpha equals to 1 and beta equals to lambda, then the PDF value is converted into like this. That is lambda power 1 x power 0 e power minus lambda x by gamma 1. So we know that gamma 1 equals to 0 factorial, 0 factorial equals to 1. So that's why the numerator value is lambda e power minus lambda x. Okay. So this is the exponential distribution formula. Now look at the mean and variance of gamma distribution of the first kind and gamma distribution of the second kind. First point is, for gamma distribution of the first kind, that means distribution involving single parameter, suppose that is alpha greater than 0. In this case, mean value variance value is equals to the parameter. That parameter here is alpha. If we put parameter is lambda, then mean and variance value is should be equals to the lambda here. So if we change the parameter here, the mean and variance values are changes corresponding that. Now the second point is gamma distribution of the second kind. For gamma distribution of the second kind means the distribution involving two parameters, that is alpha and beta. In this case, mean and variance values are, the mean value is first parameter by second parameter, that is alpha by beta, and the variance formula is first parameter by second parameter square. So this is the formula of mean and variance to the gamma distribution of the second kind. This is the mean and variance formula for the gamma distribution of the first kind. Now enter into the another important point here, where we use gamma distribution, in which situation we are going to use here. It is used when a random variable x indicates waiting times, duration time for series of events such that the time until the kth customer arrives. So in such cases, we use gamma distribution, waiting times, duration.